Okay, for those that just came in, we are waiting for a while to sort out some technical difficulties. In the meantime, you can head on to the links sent in the chat to access the Q&A and the Google Colab. Okay, let's not wait anymore. So hello everyone, good morning. Welcome to NUS Hackers X SDS Collaboration Workshop on Data Analysis Fundamentals, Numpy and Pandas. So thank you for taking your precious time to be with us here today. Yeah, I know that some of you probably usually wake up around like 11 or 12, right? So we really appreciate that you're here. And we do hope that you will learn a thing or two from this workshop. Okay, thank you for your patience and let's get started. So if you do not already know, this is one of a series of workshops that is jointly organized by NUS Hackers and NUS Statistics and Data Science Society, or SDS. So today we are at the third installment, Data Analysis Fundamentals. And next week, we will be doing data visualization with Python and Tableau. So if you are interested, please go and sign up. You learn things about the different plots and how to plot them and how to make them super beautiful. Okay. Next, a short introduction. My name is Javier, and I'm a Year 2 Data Science and Analytics student. And with me is Barath, also a Year 2 Data Science student. And Keith, a Year 2 Business Analytics student.
Hello.
Okay, so very simple objectives for today is just NumPy and its basic functions and applications and Pandas. Okay. So for all of you who just arrived, we'll be doing everything on Colab. So Keith, could you send the link again in chat? So just a reminder, once you click into this, please go to the top left and click copy to drive. Okay, you don't want to have everything you've done today be gone when you leave the session. Okay. Remember, click the copy to drive. Okay. And next, we are hosting our Q&A session on Slido. And Keith will be sending the link to the chat. So please head on over there and ask if you have any questions. Okay, without further ado, let's jump right into it and have Barath take you through the NumPy portion. Barath, please.
Thank you, Javier. All right. Good morning, everyone. So let's just get down to business right this moment. So for this portion of the workshop, I will be covering NumPy and we'll be doing this over Google Colab. So I'll just give you a quick refresher on how Google Colab works so that anyone who has missed the other two workshops isn't lost. So just give me a second. Yeah, all right. So this is your copy of the Google Colab. So what you should probably be doing is in order to run, so Google Colab is basically split into cells. It's built off of the IPython architecture. So you basically, I can either press Shift return or Command Enter to run a cell, right? So each cell is basically a small bit of code. So as you basically run the cells in sequence, as we have basically created like a sequence of steps that we will be following for today's tutorial. So you'll get this message usually. So you can just click run anyway, and that should be good. So it'll take a while for it to start up, but you will see the result of it. So you will see the result of it. Everyone good with it? Just put like a thumbs up, a reaction in the chat if you're good with it. All right. That's great. Yep, as you can see. All right, so now for my personal part, I will be presenting it on Jupyter using a plugin known as Rise. So it basically just blows up the code and makes it so that each cell becomes like a slide. So it's easier for you to watch, and I can also edit it live. With that out of the way, let's get started. So everyone ready with the first cell? Yep, sounds good. All right. So Numpy. So Numpy is quite the interesting package. It's one of the core packages upon which a lot of other packages in Python are built. So it is short for numerical Python. It introduces a lot of useful mathematical functions such as RNG generation, linear algebra, Fourier transforms, and so much more. Like almost anything can be done using NumPy. So at the heart of NumPy is a powerful new data structure that is provided by it, the n-dimensional array. And the n-dimensional array allows you to do quite a few different types of operations. And all of this is done faster in native Python. So let's get started with it. So let us first run this. So we will import NumPy as NP. So let's print out the version of NumPy that is installed. So you should get something close to this number. It doesn't have to be exact. It won't really make a difference as long as it's not terribly outdated. Next. Let's get started at the basics of NumPy, which is the NumPy array. So a NumPy array on its surface can look similar-ish to a list. They index and slice the same way, which we'll look into a bit later. So it allows for fast operations and occupies less memory than a list. And the actual name of the NumPy array is known as the n-dimensional array. Why is it called the n-dimensional array? We will see. All right, so you basically create a NumPy array using the np.array command. So in this case, we have imported NumPy under an alias np. So we will basically be saying the array command of np, for example. So our array ARR is can be created from a list or from a tuple. And as you can see, the type of it is the numpy.nd array. Now, this might be all well and good, right? Now, you might be thinking, okay, why is it called the n-dimensional array? Okay, we'll get to that. But first, why do we need an n-dimensional array? Well, n-dimensional arrays are really useful for representing stuff like matrices, vectors, tensors, and all of these objects are extremely important in fields such as physics, mathematics, and machine learning, most of all. So how NumPy actually, now let's look at how NumPy actually represents these array dimensions. So it stores all of the dimensions in a parameter known in, it stores everything in a parameter known as, in an attribute known as the dot shape attribute of an array. So it will represent it as a tuple of integers. Now that might not be so clear as of now, but then we will go through a few examples. So let us start with the simplest array, which is a zero-dimensional array. In this case, it is basically just a scalar. Now keep in mind, this is different from a 1D array with just one element. This is a zero-dimensional array. So what we have here is that this prints out the shape of the array. And over here, the shape is represented as an empty tuple. This means that the dimension of this is 0. Now, we can now look into our old friend that we've seen before, the 1D array. So if we print this guy out, we see that we have a 1D array. So in this case, and we have a shape, which is 3 comma. So this basically means that this is a tuple with one entry. So this just means that this has only one dimension and it has a size of 3 in that one dimension. Everyone following along? Just put a thumbs up or a check mark if you are. All right. Then in that case, let's move on. Now, let's think about how we can create an array of zeros of a specified shape. So we specify the shape inside a tuple. So for example, let us see that we here want to create an array of 4 rows and 3 columns. Here we basically say, here we put 4 first and then 3 later. So, and we call the np.zeros command. So if we run the code in the cell, we see that we have a 2D array of zeros. So over here, 1, 2, 3, 4, 4 rows, 1, 2, 3, 3 columns. Now we have the shape of the ND array, which is 4, 3. Everyone following along? All right, we have a few more examples, so don't worry. Now let's create a 2D array from a list of lists. So for example, we have this list over here. So this list contains 2 lists as its elements, 1, 2, 3, and 4, 5, 6. Now we basically say 2D is the create an NP array from this. So if we run this code, we see that we have created 1, 2, 3, 4, 5, 6. And this has 2 rows and 3 columns, 1, 2, 1, 2, 3. Now, suppose if you wanted to do, if you didn't want to create an array of zeros, suppose we wanted to create an array of all ones. Well, we have the np.ones command for that. So if we wanted to create an array of, say, 2 rows and 4 columns, we can. So far, pretty simple. Now, here, this is a visual representation of what we've been doing so far. So this basically shows us a 1D array is just like a linear layout of them. 2D array just represents them as a sort of a table structure, and a 3D array, you can think of it as a sort of cube. So we will get back to this. Representation a bit later. Now, let us think about how we make a 3D array. So we have our 3D, which basically has okay. So let's just create the code first. This is run the code first. Now we basically have in this case the shape is 2, 3, 4. What does that mean? Okay. So if we look at our overall array over here, we see that there are 2 sub arrays inside, right? So each subarray is its own 2D array, and each of these 2D arrays, so therefore there are 2 subarrays in this. So therefore you basically have the first dimension as being 2. Now our second dimension is going to be the number of rows in each of our subarrays. So for example, we basically have 1, 2, 3 over here, 1, 2, 3 over here. Then we have our next row. Then we have our next part, which is 4. That tells you the number of columns in each subarray, which is 1, 2, 3, 4, 1, 2, 3, 4. So you can actually extend this towards n dimensions. And let's get back to the graphic now. So if you see, we have a bunch of layers in this cube, right? So what we can say is that each layer down on this axis 0 is going to be our first. Each layer on axis 0 is going to be each subarray. And then on each subarray, you basically have a certain number of rows and a certain number of columns. Does everyone understand this? All right. All right. So now let us look into how we can slice and index these arrays. So for 1D arrays, slicing and indexing just works basically the same as Python lists. But for 2D and higher dimensional arrays, we simply state the slices and indices that we want, and then we separate them by commas. So we will have to give a slice for every dimension that we want. Now, what does this mean? Let's see. Okay. So suppose if I wanted to get the first 3 elements of my 1D array. Now, please remember, Python indexing starts from 0 and the and it is non-inclusive of the end. So what we want to do is we want to get the first 3 elements, right? So we can just put :3, right? And if we run this code, we see our original array was 1, 2, 3, 4. But now our slice array is just 1, 2, 3. All right. Now, suppose if we wanted to get this first row and the second and third columns from a 2D array. Now, let's think about how we're going to tackle this. If we look at our IC, all right, so let us look at our original array first. So we want to get the first row. So basically, that means that our first dimension is going to have to be 0, right? Because Python counts up from 0. Now, then for our columns, we're going to have to specify the slice of the columns. So this is 1, 2, 3. This is 0, 1, 2, right? So what we'd want to do is we'd basically say 1, 2, 3, because 1 to 3 gives you 1 to 2. In 1 : 3 gives you 1, 2, because again, non-inclusive of the end index. So if we run this code right here, we see that our sliced array is 2, 3, which makes sense, right? This is what we want because we have taken our first row and the second and third columns. So 2, 3, 2, 3. All right, let's go over something a bit more advanced, which is changing out multiple entries. So suppose if in our 3D array over here, we wanted to change out the second layer's second row with this specified list of values, right? So the second layer is over here, right? And we wanted to change the second row of the second layer. So we want to change this. So how would we go about indexing this? Well, let's index it like so. Okay, so I want my second layer first, right? So I will basically first go for a 1 as my first dimension. Then I want my second row of the second layer. Second row, again, 0 base indexing, 0, 1. So we put the index 1 for the second row. Now for the second, so now we want to replace the entirety of the second row. To replace the entirety of a row, we just put a colon, right? That's it. If we want to include all elements along that axis, we just include a colon. Now, if we run this code right here, we see that we successfully modified our 3D array in the way that we wanted to, right? And you can play around with this code. You can basically say, let's say 2 is this, which gives you this which gives you this, for example. This is store it to its original, right? So you can actually play around with the rows and columns, and then you can modify your 3D array how much you want. I highly encourage you to play around with this. All right. So let us look at why we actually care about arrays, because n-dimensional indexing and stuff like that is all well and good. But arrays' true genius actually comes in the way that they handle broadcasting. Now, what is broadcasting exactly? Broadcasting basically means that an operation can be carried out on every single element of the array. And this is much faster than a typical for loop that you would normally have to do if you wanted to do this stuff for a list. Now, why is this important? Well, then you basically have a lot of operations that require you to consider every single element in the list. For example, matrix multiplication, or something, or some sort of scaling, or some sort of data pre-processing, for example. So for these cases, we need to have a quick way to change every single element in an array. And broadcasting is the way that we do that. So let us actually do a little bit of a challenge, shall we? Here I have 2 functions. One basically adds 2 lists together by looping through the indices in the list and adding each element to a list to an output list. So our second function instead just simply adds array 1 and array 2. All right. So we are running this through 1,000,000 iterations, and we will see the time it takes for 2 lists to be added and for 2 arrays to be added. So let us run this. This will take a while, especially on Google Colab. So let's see. All right. So as you can see, This took about 720 nanoseconds to do this operation once. Well, over here, this took us 378 nanoseconds, which is about half of the amount. And the thing is that as you can experiment by yourself later on, the larger the size of your list and array, corresponding array, the larger the difference is going to be. So you can actually see that that broadcasting actually really speeds up array operations. Now, on your Colab, you might not see these exact same values, but then you will see that the time is about half, because Colab basically runs a significant amount of caching and stuff like that, because you're running it on Google servers, not your own computer. So they don't want to run the same computation multiple times. But you should still see that the NumPy array is significantly faster than the Python list at this operation. Now, array broadcasting is not really a fix-all tool. One key thing is that the array must be of similar or compatible shape. So suppose if we have R and R1. So R is basically 1, 2, 3, 4, which is 4, which has shape 4, and R1 has shape 5. So in this case, they cannot be broadcast together because for broadcasting, we need operators of compatible shape. So for addition, this means that they must be of the same shape. For subtraction, same for subtraction. For matrix multiplication, that means that they have to be compatible with each other by normal linear algebra rules, and so on and so forth. So be very careful about your array shape before you get into broadcasting. Now, you might be thinking, okay, broadcasting sounds really amazing, but there is no free lunch in this world. So there is a price that we must pay for the speed offered by the NumPy array. There are two restrictions on NumPy array, and they are that all elements must be of the same type and arrays cannot be resized. Now, NumPy does do some sort of implicit typecasting, but then that isn't really important for our purposes today. Now, arrays, so that basically means that once you create an array, you are basically stuck with that shape with that size of the array. You cannot add or you cannot remove elements. You can change elements and you can reshape an array if you keep the number of elements the same, but you cannot add or remove elements. Now, we will see why that is the case. So the restrictions stem from how NumPy arrays actually get their speed. Because the thing is that NumPy is written in C. The code is compiled into C. So that basically means that we are actually able to exploit the speed of C. So what ends speed of C, since it's a much lower level language, much closer to the metal. And so, so that basically means that we exploit the fact that arrays are stored in contiguous areas in memory to exploit memory savings, not having to deal with pointers and so on and so forth. And NumPy being written in C benefits from the speed of C. So basically, if you have a NumPy way of doing something and a native Python way of doing something, do it the NumPy way because it's going to be faster. Right. Now, NumPy has a ton of utility functions. If we wanted to go over them all, we'd be here all day. So instead, let's just examine a few general utility functions. So suppose if we wanted to find out the mean of an array, we can do that, np.mean. If we wanted to find out the standard deviation for the values in an array, we can do that as well, np.std of the array, right? Then if we wanted to do a range, so suppose if we wanted to return a list of numbers given a step size between a start and an end point, we can do that, or we can return a specified number of evenly spaced points between two numbers. Let's actually play around with the step size a bit, no? So what if I did a 0.1? Well, we see 2, 2.1, 2.3, so on and so forth. Now, suppose if I wanted to count down, let's say that I wanted to go from 2 to 1. And let's say that my step size was minus 0.1. That can be done as well. Now, we basically have linspace. Now we basically can play around with linspace as well. Suppose if we wanted 5 evenly spaced points, sure, we can do that. 4, definitely. 1 at 100, that can be done as well. Let's just return it to a more manageable number. Now, here's how you reshape an array. So you basically do add or reshape, and it is important that the rows times that the product of the dimensions is the same, because that is the number of elements in your array. You cannot add elements in an array. That is the whole point of NumPy arrays. Now, NumPy also offers support for many linear algebra functions, which is very important for people who are in fields like physics, engineering, mathematics, and especially deep learning and machine learning. So, by the way, the inbuilt NumPy matrix object is deprecated. So instead, we will use NumPy arrays for matrix computations. So let's just create our matrices and vectors. Now, here are the basic operations in NumPy. So it supports addition, inner products, matrix multiplication, and all of them take advantage of broadcasting. It supports many advanced operations as well. And for now, we will go through some of them. So we'll just print out matrix A, matrix B, matrix C, just as a refresher for everyone. And let's get started. Addition. All right. Checks out. Matrix multiplication. That checks out as well. Now you see that we use the @ operator for matrix multiplication. We do not use the asterisk, and there's a reason why. The asterisk is for element-wise product, whereas matrix products are going to be @. And you can actually verify by looking at matrix A and matrix C that those two are indeed correct. Now, here's a quick refresher, and let us try this out. This is a matrix times a vector. That can be done as well. We can even take the transpose of a matrix, which is np.transpose. We can take the dot product of two vectors, as you can see over here. We can even take the norm of a vector, and we have an even more advanced application, finding out the eigenvalues and the eigenvectors of a number. So of a matrix. So over here, this just gives us an array of the eigenvalues, and this gives us the array of the corresponding eigenvectors. All right, so here are a couple of exercises. So I will give you guys like 5 minutes to go through these exercises and try and solve them. The solutions will be provided to you at the end of the class, so there shouldn't be much issues with that. So how about all right, so let us all work on these exercises, and I will give you the solution at 10:34. Can everyone just put a tick mark? Can everyone use a tick mark reaction if they're okay with it? All right, sure. All right, it's 10:34. Let's get started. So we will first get started with the first part of, I'll just solve the first 2 bits. So we'll have to create a test array, right? Test array, and what is the size? It's going to be, it has to be of shape 2, 3, 3. So we basically say test array is equal to np.zeros. And we have to specify the shape over here. Now, what we have to do is we have to create. So now, we basically, I'll only solve question 2, and the rest you can do by yourself, knowing question 2. So we'll have to replace the first row, or for the first layer, we'll have to replace the first row with 2, 3, 1. All right, let's do that. So we get the first row. So second, first layer, first row. So this should be 2, 3, 1. And if we print out our test array, yep. As you can see, we've actually done the first bit of the second question. Now for the second bit where we have to replace columns. Now what we have to do is that we have to display test array. Now 0, and we want to replace our third column with 1 for 1. All right, so that basically means that we have to take all of the elements along the row axis, and then we have to basically take the third column, so that would be our second, and that would be 1, 4, 1, right? And then now we can just print test array, and you can see, yep, as you can see, our third column has become 1 for 1. So knowing this, you should be able to work out the rest for yourself. Now, going ahead, the only way to learn more and get better at NumPy is to simply play around with it. NumPy is a vast and a very, very versatile package. And on your data science journey, you'll actually see quite a few, you'll actually see NumPy a lot. Most of our big packages such as SciPy and stuff like sklearn are also built on top of NumPy. And the NumPy documentation, and I've linked to it over here, are just an excellent resource regardless of your skill level. Happy coding. Right?
Thank you, Barath. Give me a moment. Let me share my screen. Okay. Hello, everyone. I'm Keith. I'll be going through the first part of the Pandas portion. So before we get started, I just want to give the disclaimer that whatever we are going through today are very basic. The Pandas library is very extensive, similar to NumPy. And what we are going through is just the very start and the common functions that we use when you're dealing with this library. So we encourage all of you to explore further on your own and to read the documentations. So without further ado, let's go straight in. So the Pandas portion will be conducted through Google Colab. So there's no need to install it because we can import straight away from the Colab. But if you want to use the Pandas library on your local machine, you can copy this code, the pip install pandas, onto your command terminal. So let's go straight in by importing the Pandas library. So the first thing I want to talk about will be the Pandas series. So what is a Pandas series? This definition is lifted directly from the Pandas documentation. So the series is a one-dimensional labeled array capable of holding any data type. So you can think of it as a table with one column. So we'll go straight to creating series object. So the easiest way to create a series object would be to use a list to input the values that we want to create the series with. So all we need to do is call a pd.series and input the list with the elements we want. So in this case, we want 1, 2, 3. And by running this, it'll create the series object and with the variable s1. So let's print it out. So you will see that on the left column, there's 0, 1, 2, and the right column is 1, 2, 3. So the left column is actually the index labels. In this case, when we call the series function, we did not actually specify any labels we want to put. So by default, the labels would be the index positions of the element. So you recall that Python uses zero indexing, hence the very first element is actually at index 0. So the red column shows the values that we input in, which is 1, 2, and 3. And you can see down here, dtype in 64. It just means that the data type that this series contains is of integer. So if you have to print the s1.d type, it shows as an integer as well. So we can look at the type of this object, and not surprisingly, they show that it's a series object. So if the variable is a series and you use a type function, they will show this. Okay, so let's move on. So let's create a new series object with labels that we want to specify. So in this case, you want to specify the index labels be follow SES Society Instagram. So all of you here who have not followed, please do give us a follow. Okay, so let's go ahead and create this. And if you were to see what S2 is right now, you see that instead of the index labels being 0, 1, 2, it actually is the follow SES Society Instagram, which we specified. So that's how simple creating a series object is. So there's another way that we can actually create a series object as well, and that's using a dictionary. So recall that a dictionary is actually a key value mapping. So we map this key, for example, the B key to the value of 2.0, and the A key to the value of 2.0 as well, and for D and C as well. So we can include this dictionary into the series function and run the function as well. And it will actually give a series object with the index labels as the key values, and the right column, the elements, will be the values that we specify in the dictionary. So this is another method of creating a series object. Okay, let's go on and create another series2 object with the index ABC for the exercises below. So this is the very first exercise I have for you. We'll be doing it like a code along the way. So create a series3 object with index labels ED, CD, A, and values 5, 4, 3, 2, 1 in that order. So let's go straight into it. Series3 pd.series, and the values we want to input would be 5, 4, 3, 2, 1. Index would be E, and A. Okay, here. So if you take a look at series 3, right, it looks like what we represented here. This is how it should look like, and this is what comes out. So creating a series object is just that simple. So moving along, we'll go through arithmetic operations on series object. So recall what Bharat said about NumPy broadcasting. By performing arithmetic operations, the value is broadcasted throughout every element in the object. So this happens in the series object as well. So if we were to call series 1 plus 3, 3 will be added to every element in series 1. And if we were to call series 2 multiplied by 5, every element in series 2 will be multiplied by 5 as well. So this is very similar to NumPy broadcasting. So let's try out something else. What if we were to do arithmetic operations with two series objects together? So in this case, let me try adding series 1 and 2 together. So you'll notice that there's a very weird value here at index label D, which is NaN, which actually stands for not a number. So why this happens is because series 2 does not actually have the fourth element with index D, whereas series 1 has. So if you can see, every element was matched by their index labels and added together. So in this case, series 1 has an element D, and series 2 does not have an element D. Hence, it actually threw a null value, not a number. So how can we overcome this? We can, Pandas library actually have binary operations, like the dot add, dot subtract, and a dot multiply. So we can actually call the dot add, which actually adds the two series together. But the results come out is actually still the same. You'll see that at index position D is still not a number. However, the difference is that you can specify a parameter called fill value. And by specifying to 0, right, it actually fills in the missing value as 0 for series 2. Because in this case, when you do the operation, series 2 actually has the missing value at index position D. So it will fill that position with 0, and you'll be able to add the two series together now. So it comes out 4 because series 1 is actually have value of 4 and next position D. So 4 plus 0 equals to 4, and that's why it comes out at 4 over here. So there's the subtract, there's a multiply, and there's a division as well. So if you were to run this, you actually take series 1, subtract series 2, and series 1 dot multiply series 1 dot div. Series 1 dot div basically takes series 1 divided by series 2. And because series 2 at index position D is a 0, it throws off an INF because of the 0 division error. So I'll go straight to common series functions that we use. So you'll notice series 1 and series 3 that we created on top. Let's look at series 1 again. Series 1 index positions are B, A, D, C. So it's not actually in order. So what we can do is that we can call the sort index method, which sorts it in order. So it comes out A, B, C, D. Let's take a look at series 1 again. You'll notice that it's not sorted permanently. This is because we did not actually specify the in-place parameter to be true. By default, this is false. So as you see up here, we did not specify anything, so they took it as false. So if you replace it to be true, it actually sorts the index permanently. And if you to call series 1 again, it's permanently in place right now. So there's another parameter called ascending. By default, it's true. So if you were to change it to false as well, it will go in decreasing order, DCBA. So other common functions will be count, which return the number of values there is in series 1. In this case, there are 4 different values. There are 4 values. And the number of unique values, which is n unique, returns how many unique values there are in this series object. In this case, there are only 3 unique values because 2 of the index positions have the same value. So there's only 3 unique values. By calling the unique function, we actually get back an array of all the unique values we have in this series object. The last part of the series part of the pandas library is about data retrieval. So recall from a list and a numpy, you can actually, and a numpy array, you can actually retrieve the element in the series using an index position by calling in the square brackets. So if you have to, we can do that. We can do the same with pandas series, and if you have to do this, we get 2, which is at index position 1. So the difference is that for series object, you can actually retrieve the element using its label rather than its index position. So by calling C, we actually retrieve the element that's at index position C as specified when we are creating the series object. So last but not least, we can retrieve a subset of the series by adding a colon in between. So recall that the very first index is included in what is being returned, and the very last index is not included. So what this does, it actually retrieves the elements from index position 1 and index position 2 because 3 is not included in the return value. So if you run this, you actually get B and C because B is the second element, which is at index position 1, and C is at the third element at index position 2. So we have come to the end of the pandas series portion of this part. Next up will be pandas data frame. But before this, let's go for a short 10 minutes break. And after you come back, Javier will be going through the data frame part.
Hi, so let's all go for a break now. And I'm supposed to play some nice music. So can you all hear the music? Okay, can someone indicate yes, no?
Yes, we can hear.
Okay, thank you, Ryan. Okay, let's go for a break. I will be starting very soon. You can start waking up now. Hi, okay, it's 10:57 now. Sorry, there's no more coming music. You've got to listen to my voice now. Okay, so welcome back from the break. I hope you all went to the toilet and everything, because for the next 3 hours, we won't be having any more breaks. Okay, just kidding. We try to release you all before lunch, okay? So let's get started. If you can see, right, there are corgis and kittens are running on top of my screen. So I've been told that it might be a little bit distracting, so I'm gonna turn it off. So here's an Easter egg for you. If you want corgis or kittens, you can go to the top right, press the setting button, and you go to miscellaneous and turn it on. Okay. Okay, let's get started. So we've just finished the pandas series portion. Now let's move on to data frame. So data frame is one of the other very popular, the most important data structure in the pandas library. So a series is a one-dimensional table. However, a data frame is two-dimensional. So if you see here, they can say you can think of it like a spreadsheet. So here's a pictorial representation. So you have different rows and you have many columns. So you have column names and index labels, or sometimes I'll call them index names. So all here, sometimes you'll see NaN, or actually more often than not, you will see NaN, which actually stands for not a number. But you can see them anywhere in the table, and you can just treat it as a missing value. Okay, so how do we create data frame? So we can, as like series, there are many different ways to do it. So we start off with pd.dataframe, and then we can pass in a dictionary. So the dictionary key would be the column name, and then the values would be those values in that specific column. So you see we have column 1, ABC, and column 2, DEF. So yeah, that's quite self-explanatory. So if you see by default, right, the index labels will be 0, 1, and 2, 0, 1, 2, 3, 4, 5, and so on and so forth. Okay. Now, method 2, we can use series to create it. So you type the same thing, pd.dataframe, and then the column name that you want and the series you want to put in. So we're going to use the series from just now, and let's see what happens. Okay, so you notice that there's an NaN column here, NaN value. So why is that so? Okay, if you've forgotten what the series looks like, let's print it out. Series 2. Okay, and you see, because series 2, it doesn't have an index name with D. So over here, they'll just replace it with an NaN. And you notice we didn't specify specifically the index. However, the function itself will be smart enough to use the index from the series. Okay, so the third method, we can use a list of lists. So if you look inside here, this is one list, and this is another list, and both of these lists are inside a bigger list. Okay, so each list represents each column. Okay, and for this, we also can specify the index names that we want using the index keyword, and the column names using the columns keyword. And yeah, this is what you get. So now a short exercise should be quite easy, is to create a data frame that looks something like that. Okay, let's just go review because this is quite easy. Okay, so write the data frame 4 using pd data frame. And so which method should you use, you might ask? So usually I would like to use the first method. It's actually also my favorite method, which is just specifying it in a dictionary because it's so straightforward. So dictionary, so we got to write the curly braces and then the column names. So column 1, okay, it has 5, 7, and 9. So write 5, 7, 9. Column 2 has 6, 8, and 10. Okay, is that all? So our column names and our values are correct. So now what's left is the index. So as before, you can specify the index using the index keyword, and then you just write whatever you want. EFG. Okay, yeah, easy, right? Okay, so let's move on. So next is concatenating data frame. So what does concatenating mean? It just means you can just see it as putting two data frames together. So why do we want to do this? Sometimes we might have multiple data sets and we want to do some analysis on them, but it doesn't really make sense to do it one by one. So we want to put it all together and do a whole analysis on the entire thing. So there are two main ways we can do this. One is concat and one is merge. Okay, so concat is the more straightforward and easy one, and you can do it by writing pd.concat, and then you pass in the data frames that you want to be put together. So for this, you can put in as many data frames as you want, and you see by default it stacks them on top of one another in the order that you gave them. So if you can see at the start here, the first 3 rows are data frame 1, then the next 4 rows data frame 2, and the last 2 rows data frame 3. Okay, but okay, what if you want to put them side by side instead? Okay, this is where you use the axis keyword. Okay, let me write here, axis. By default, right, axis is equal to 0. This is stacked on top of one another. Okay, and if you want to put them side by side, you have to specify axis equal to 1. Okay, see? So you notice there is a lot of NaNs here. So why does this happen? Okay, because if you notice, each data frame has different index labels. So there's they can't put it in the same row because it's not the same. So for those, they have to create new rows for each data frame. So and then they'll just fill all the empty spaces with NaN. So yeah, let me show you. Axis equals 0 is the default, and you have something like the one that we did before. Okay, so what if, okay, now you look at the index labels, right? It's quite ugly and it doesn't really provide any useful information. So what if we want a nicer looking index? Okay, this is where we can use the ignore index keyword. Ignore index. Okay, so you just write ignore index equals to false, true. What this means is that we want to ignore the original data frames index. So if you run this, you see that it has a really nice running index starting from 0, 1, 2, 3, 4, and all the way. Okay, so pd.concat is quite simple and straightforward. And next, we have the merge function. So okay, this merge function is a little bit complicated, but I'll try my best to explain to you guys. So this is a visual representation of the different merge that we can do. Okay, you see here it says join, but so if you hear me say merge or join, I'm actually using it interchangeably. So you can just treat it as the same thing. So we have a left join, an inner join, a right join, and an outer join. So there's also a cross join, but that one is, I don't know who actually uses that. Okay, so okay, let's just show you using an example, right? Okay, please, we run this cell. We create 2 data frames here. Okay, and if you see here, data frame 5 and data frame 6, they have the one similar column name, which is column 1. Okay, and column 2 and 3 is they are separate. Okay, it's not the same. Okay, so how do we use merge? Okay, so unlike concat, you see, just now I said concat, you can put in as many data frames as you want in a list, right? But if you use merge, you only can merge 2 data frames at the same time. So you can write df5.merge df6. And okay, this will work sometimes, or most of the times. However, sometimes you want to be more explicit with how you use the merge so that it's clear. Okay, and later I'll explain to you why it returns something like that. Okay, so as I said before, there are different kinds of joins or merge that we can have. And how do we tell the function which join we want to use? So we use the how keyword. So we start off with the same thing, df5.merge df6. Okay, then we want to tell them how are we supposed to merge this. So by default, it is an inner join. So we write inner. And after specifying how, you want to tell them which column they want to join on. Okay, so let me try giving you a visual analogy or something. Okay, so concat, right? You can see it as taking 2 data frames, and then you just stick them together like that, either side by side or on top of one another. Okay, however, merge, right? You can think of it as 2 data frames, and then you want to push them together such that it combines, and then there is an overlap. Okay, so this overlap is what you tell them using the on keyword. So you write inner join on, and so if you look at data frame 5 and data frame 6, right, where can we actually overlap on? So it should be quite clear, right? Only column 1, because it's the only common column. So you write column 1. And then we play. And you notice this is the same as before. However, this is more explicit because now if someone reads your code, they know that okay, you're doing an inner join and you want the overlap to be on column 1. Okay, now I'll show you. Okay, so why does this happen? Okay, so this is a bit complicated. So let me try annotating on the screen. Okay, now we see that. We see that we want inner join, right? So if you scroll up here, inner join is inner join is this part over here, which means that it's the intersection of both the data frames. Okay, so what it means is when you write inner join, what the function is going to do is look at the column which you want them to overlap on, which is in this case we say column 1. So they're going to look through this entire column 1 and data frame 6 column 1. Okay, sorry for the bad writing. Okay, and then because now you say inner, which means they want the intersection of both data frames. So they will look through the values, which is here is A, B, C, and data frame is A, D, E. And then they will pick out the matching value. In this case, it's only A. And they'll take that row from that data frame. So they'll take this row from data frame 5 and this row from data frame 6. Okay. So so you see that's why we only have 1 row, because A is the matching value, right? And then D is from data frame 5, and then 4 is on data frame 6. Okay, now let's show you using another example. Now we write df5.merge. You want to merge with df6, how? Okay, using left join, for example, and on column 1. So you notice, right? There's only 1 choice for the on because there's only 1 common column name. So we have to write on column 1. Let's see what they give. Okay, now you see that it actually returns more rows. So why? So we scroll up here again. We see left join. Left join is this entire circle. Okay, what it means is that it wants all the rows of the left data frame. In our case, it's data frame 5. And then there's this overlapping part, which means the intersection from means they only want the row in data frame 6 with matching values with data frame 5 on column 1. Okay, let me draw it out again. So same thing, they will look through both the column 1s And then they find the values that match, which is A. Okay. And then, because now it's a left join, so it means that they want the entire, all the rows of data frame 5, but only the matching value, the row with matching value in data frame 6, which is the A. So they're going to return you this part. Okay, and we can see here that this is what we get. The entire data frame 5, and then only the row in data frame 6 with the matching value, which is A. And the rest, they just put in an NaN. Okay, so I know this might be a bit hard to understand, but I hope my explanation was good enough. Okay, now let's move on to using real data. Okay, before that, I need to make a disclaimer that this data set is obtained from our World in Data, which has a lot of data that you can find, and it's free, open source. Okay, the original data, you can click on this link to go and download, or you can find it on Kaggle. But the Kaggle one may not be updated. So for the purpose of this workshop today, we have altered the data set, and we only pick out a few rows, okay, or not, the thing will be too big. And we have removed some values from it, just to show you the different functions that we can use. Okay, so how do we load in data? There's actually quite a few ways, and some really complicated and some easier ways. And here I listed out 2 simple ways to do it. Okay, the first one is you can just read it directly from a URL. So what the function we usually use is pd.read_csv. So CSV stands for comma separated value, and actually your Excel is inherently also a CSV object, or anything. If you see a .csv, then yeah, there is a CSV object. So this URL, right, when you open it, it leads you to a Google spreadsheet. So we can do this, pd.read_csv, see it works, okay? Or we can do this, if you are familiar with Git, you can also do something like that. You can clone the repository. Okay, so this is my repository. I've uploaded the dataset there. And then if you click on the files here, you can see that now there is a new folder. Okay, initially there isn't this folder here. After I clone it, this folder will appear. And inside here, you can see is the dataset.csv. So after that, you can just read it as you normally do using the path. So this is in Numpy Pandas workshop / then the file name, COVID dataset altered.csv. Okay, so these are 2 of the simplest methods. And there are other methods which you can go and explore on your own. Okay, so now after loading in the data, right? So what we want to do first, before doing any analysis, okay, this is part of the analysis also, is to observe the data. So what does the data tell us, and all the basic information. So first thing you want to maybe figure out is how big is this data set, right? So how do you ask, or how do you find out? So we can use the .df.shape. Okay, you see that it returns a tuple of two numbers. So the first number is the number of rows, and the second number is the number of columns. Okay, now what if you want simple statistics about the data? You can use df.describe. And you see, usually, by default, it returns all the numerical columns, which means the column with numbers only. So you can see that they have count, mean, standard deviation, and all this. Okay, and okay, what if you want more percentiles? So we can use the percentile keyword, percentile. So df.describe, right, percentiles equals, and then here you put in a list of percentiles you want. But I'll be using what we've learned just now in the NumPy portion, is numpy.arrange. So I want a range of numbers from 0 to 1 with a step size of 0.2. So, and you see that now we have more percentiles, and each of them with a difference of 30%. Okay, now if you notice, this is just now we df.shape, right? We have 11 columns, but now we only have 7 columns. Okay, what if because these are the only numerical columns, and the other columns are what we call objects, or just, you can just treat it as not numbers. Okay, so how do you want to receive information about them? You can use the include keyword, means you want to include them in the description. So there are different ways we can say, let's say we want everything, we can write include all. And you see you return everything, including this ISO code, continent, location, and date. Because these are not integers, they're not numbers, so they are considered objects. And they cannot have, it doesn't make sense to have mean, standard deviation, and all this. So they will just return us the count, how many unique values there are, the top value, and the frequency. Okay, if you just want the objects, you can just type in O, BO object. And you returns you these 4 columns. Okay, next you want to know, okay, so what types of data do I have in my data set? So they are quite straightforward, right? It's df.dtypes for data types. And note here, right, we don't write parentheses. Okay, so they say, okay, 4 object columns, like I say over here, and the rest are float. Float is just any number with a decimal place. Okay, now another very useful function that we have is df.info. So this actually shows us useful information. Okay, we just see. So from here, right, you can see it actually shows you the number of entries, 2321. So it just means the number of rows, and then it also tells you the number of columns. And at the right here, you can see dtype. So basically, this info, df.info, combines the function of df.shape and df.dtypes, and then they provide extra stuff on top of that. So this is the important thing that I'm saying. Okay, they will return the non-null count. So what does that mean? It's just the number of non-missing values. So if you see here, we have 2,321 rows, and for this ISO code column, there is 2,321 non-null. So you know it's a good column because there's no missing data. However, if you look at this last row, total vaccinations, there's only 625. So it means that you're going to expect a lot of missing values in this column. So very useful. Okay, so now, after we know all these things about the data, right? So we want to have a look at the actual data itself. But usually you don't want to just type in df because they'll show you everything. And sometimes the rows, the amount of data you can have is like more than a few 100,000 rows, which might lag your computer. So you just want to get a peek of the data. So you can write df.8. And by default, it returns you the first 5 rows. So if you want to see more, you can just type a number here, like let's say you want to see 10 for 10. So you write 10 and then they return you the first 10. Okay. Similarly, you can see the tail of the data, which is the bottom few rows using df.tail. Okay. So if you look here, you can see that location we have like China, and then at the bottom we have Singapore. So maybe you want to know how many different countries there are and how many rows of each country there are. So you can use this thing called value counts. Okay. If you don't understand this, I will be going through this shortly. So this just returns you all the values in the location column. So you write value counts and you see that there are 583 rows of China, 581 Malaysia, 579 Singapore, and 575 India. Or you can use this unique keyword to see all the different unique values there are. And yes, you notice that in this there is an NaN here, which what does it mean? Missing data. Right? So there are rows in the location column that is missing. Okay, so moving on. How do you want to get the data to work with, right? We need to get, sometimes you want to work with specific rows or columns or specific values by itself. So the two main ways that you can do it is using these two functions called loc or LOC and ILOC. So it may seem very familiar, but then there are, it may seem very similar, but then there are quite a bit of differences. And here's a summary. Okay, we just go through the examples for you to understand. Okay, take note that how I remember these two functions is by the first letter. You see LOC, loc, is based on the labels because the first letter is L. And ILOC is based on index. Okay, so if you want to get rows of data, okay, we can just put the row, okay, if you use lock, remember I say it's based on label, right? So you can put the index label inside here. And they return you the entire row. And if you want to use ilock, instead of putting the index label, you put the index. So the difference is one of them is the name of the index, the other one is index as in the position. So this is at index 1. Okay. Now, what if you want a few rows? So you can specify it using, you can use lock or ilock again. So for lock, you can say, you can put in 1:3. Okay, this returns you the three rows. Okay, then what if we want the same number of, okay, can we do the same thing with ilock? And then okay, so you might think, why is this, why are both of these different? Okay, so as I said above, lock is based on labels. So for this, what are you telling it is you want the rows with the index names 1, 2, and 3. However, for ilock, it's based on index. So you want it from index 1, 2, but not including 3. Okay, confusing, right? If you scroll up here, you see this is what they say. N is included, but M is not. So why does this happen, right? Actually, I also don't really know. It's just a Python thing. Like, for example, if I type this, right, what it wants just saying is I want to get a range from 0 to 5 and put it in a list. So you see they return 0 included, 1, 2, 3, 4, and 5 not included. So yeah, this is just how it works. So pay attention to this, that if you use lock and ilock, you may not always get the same results. Okay, now we have a short exercise. So please try it out and use both lock and ilock. I'll give you about 1-2 minutes. Okay, and I play the nice music. Okay, I hope you're done because I see that I might be a bit behind time. So let's quickly go through this together. Okay, so retrieve the 3rd to 5th rows. Okay, let's try using log first. So LOC, so 3rd to 5th rows is quite straightforward, right? Is this correct? No, okay, it's not. Okay, why? Because remember that Python, we start our index count from 0. So 0, the first row is index 0. The second row is index 1, third row is index 2, and so on. So if you do this, index 3 is actually the 4th row. So what you want is actually 2 to 4. Okay, now ilock. Just got ilock. 2 to 4. And yeah, I hope you remember that it's not gonna give you the correct answer because the last number, the second number is not included. So you have to increase by 1. And there you get it. Okay. Now this is getting rows. Now we're on to getting columns. So there are also a few ways as usual. Okay, the first one is called attribute access. So this has to do with why is it called attribute is because of classes and objects, but it's not the main point of this workshop. You can just know that this works. So you write df dot and then a column name. Or you could use square brackets and put in a column name, return the same thing. Or of course you can use lock and ilock also. So if you see here, right, you think, what does this mean? So actually, iloc and loc, the first parameter there is that you put in refers to the rows, and then the second one refers to the columns. So if you put a colon here, what it means is that it's just telling them that you want all the rows, and then we comma 1, which means all the rows of the column at index 1. And you know this is the same as above. Okay, but multiple columns, we can use the square bracket, and then we put in a list of column names here. Okay, quite simple. And of course, you can use iloc and loc again. So iloc and loc can be used anywhere. It's just, yeah, it's like if you want to get rows, you want to get columns, or you want to get specific data, you can use both of these. So same thing again, colon means you want all the rows, and this time you want the columns at index 1, 2, and not including 3. So you only have 2 columns here. Okay, next exercise for you, which I think I'll do it together with you. So how do we retrieve the date, total cases, and new cases columns, right? We can use any of the methods we just learned. So the most straightforward one we can use is square brackets, and then we just add in date, total cases, and new cases. Okay, and if you want to use log, you also can. You'll notice that it's a little bit redundant. Why? Because you'll be typing something like that. Okay. Yeah, this also works. But you see that we are just typing extra stuff. So using the square brackets is easier. And of course, you also can use iloc, and you just have to key in the index of each column that you want. Okay, next, now you want, okay, both of these are getting rows and columns, but what if you want an specific exact value value? So how do we do that? So this is another exercise which I'll just do it with you again, is we can use actually a few methods. So of course, let's try with iloc first. We want the rows date column. So the hint here is that the date is in the 4th column. So if we use iloc, remember I is index based. So the 3rd row, what's the 3rd row's index? 2. So iloc 2, and the date is the 4th column. So the 4th column is what index? 3. Okay. Oh, did I get it wrong? Okay, maybe I typed here wrongly. Okay, it's supposed to be 2, 4. Okay, method 2. We can use log. So 2, index 2. Okay, in this case, right, it's not index 2, right? It's the index label that is 2. And then the column name that is date. And actually, there are other ways to do it. Let me show you also. We also can use the square bracket, and we do this. So this returns the values of the date column, and then we can index the one at the second index. Or we also could do using the attribute access, which I taught you. We have date, and we take the second one. You see, there are many ways to actually do. I'm pretty sure there are more ways to retrieve the exact same value, but these are just 4 different methods. Okay, I recommend using the iloc or log. Okay, last one. Okay, what if we don't know which column or which row our data is from? So how do we retrieve data from there? So we have, like, we only want the rows which fulfill a certain criteria or meet a certain criteria. So, okay, you can see here, I specified a list with Boolean values. So Boolean values is just like true and false, values that can only take true and false, success and fail, something like that. Okay, so I specify a list, true, false, true, true, false. And then I put this list in square brackets beside df.head. So do you remember what df.head does? It returns the first 5 rows of the data frame, right? And then I put this list with 5 Boolean values, true, false, true, true, false. So I think maybe most of you will have intuitively guessed by now what this does. And let's see if you're right. Okay, you're probably right. So what does this mean? It just means that they want the first row because it's true. They don't want the second row. They want the third row. They want the fourth row, and they don't want the last row. So yeah, this is what you get. First row, which is index 0. Then don't want the second row, so you don't have a 1. You want the third row and the fourth row, index 2 and 3, and you don't want the last row. So you don't have the index 4. Okay, so now this is for the last portion of the workshop. We'll only be using the Singapore data. So how do we use what we've learned above to just retrieve the Singapore portion? Okay, how do we work? Okay, with this logic above, right? How do we get the Singapore portion? So for example, let me show you an example, okay? Like let's say we look at the new cases column, and then we want the rows where the new cases are more than, let's say 20. Like you want to do analysis, like why, is there like a certain pattern to why these days have new cases which is more than 20? So you can use what we've learned above, how to get columns, and you write new cases. So remember, this returns you a whole column in new cases, and then you can just specify more than 20. And then this works something like the broadcasting that you've learned before. So what it does is it go through every row, and if that row is more than 20, it returns true. If it's less than 20, it returns false. Okay, if less than equals to 20, it returns false. So we see that if we provided a Boolean list in square brackets to a data frame, it returns you the rows that are true and the rows that are the rows that are true. Okay, so we just want the Singapore portion, right? And if some of you observant, okay, and it's quite obvious, if you notice, there is ISO code and there is location. So which one should we use? But so my advice is, if you don't know, you can just try both because it doesn't take very long, right? So first, let's try to get the Boolean list. So df, let's try with ISO code, and then we want the ISO code to be SGP, which is Singapore. Okay, then this returns a list of Boolean values. So we want to put this in square brackets, and we want to pass it to a data frame. So like that. Voila, you got all the rows with SGP. Okay, now let's try with location. Singapore. Okay, and you notice what's the difference? You see here, there is 582 rows using ISO code. And then if you see here, it's only 579. So remember above when we doing the value counting, then, okay, let's go up. Observing. Over here, yes, location, unique. And then you see that is a NaN here. So maybe the difference in the number of rows is because there are 2 rows which are supposed to be Singapore rows is missing. So in that case, what we want to do is use the ISO code because they have all the rows that are supposed to be Singapore. So location is, if you use location, you're gonna miss out that 2 rows which are supposed to be Singapore. So yes, take note when you are doing this, try to figure out like which is the correct column you should use. Okay, so now we've come to the end of my part, and yeah, congrats for making it here. So don't worry, we just have a small portion left which Keith will take over. Yeah, I know this might be a little bit dry and mundane because we're doing the fundamentals, but this is mundane, but it's actually a very essential process of data analysis and data science. So yeah, I promise you that once we get down the basics, right, we can move on to more interesting stuff in the future. So now, let's not waste time. I'll pass my time back to Keith to take us through the last portion of the workshop. Thank you.
Okay, hello everyone. I'm back to carry on the last part of the workshop. So the header says it's exploratory data analysis with pandas, but actually it's more of data cleaning using pandas. So right now I'm just going to go through the very common functions we use to clean the data. So take a look at the data frame that was filtered just now, df_sg. You can see that because it was filtered from the original data frame, the index does not start from 0. So what we can do is that we can reset the index using the reset index function. So what it does, it actually creates a new row with new index. So the original index row over here, the original index column was left here, which we do not want because it's actually a redundant column. So what we can do is that we can actually specify the drop parameter to be true. By default, it's false. By doing this, it returns a new data frame with the new index labels, and it drops the original index labels. Okay, so that's for resetting the index. So right now, what if we want to set the index to be a different column? In this case, we want the date to be the index column rather than the index numbers itself. So we can do the .setIndex method, specify in place equal true, and let's take a look at our data frame again. The date column was pushed forward and it replaces the index positions. So that's for the setting of index. Okay, let's explore a little bit on this date index right now. We can call the .index.dtype, which shows the data type of the index column right now. In this case, it shows an O. The O stands for object. So we do not actually want it to be an object because date is actually there's a specific data type called datetime in pandas, which allows us to utilize various functions involving time. So we want to convert this object data type to a datetime data type. So we can use the pd.toDatetime function and we input the index column itself and we reassign it back to the index. Let's take a look at this. When we print out the index data type now, you'll show the datetime 64. So right now, we have successfully converted the index column into a datetime object. So with this datetime index, we can retrieve the day, the month, and the year of the specific datetime. So if you call .index.day, it returns the day part of the datetime index. So it starts from 23rd of January. So you can see that it retrieves the day. And can retrieve the month as well. So from January all the way to August, as well as the year. So I won't go deep into what date time is. I have attached links to the end. You can take a look at your own time. For now, I'll carry on to data cleaning. So the first thing we should do when we get a new data set is to always check for null values because we do not want our data set to have missing values. So by calling the isNull function, it returns true when the element is null and false when it is not null. So it returns a new data frame like that with true and false. So it's not very practical because there's no way you can eyeball and count individually how many there are. So what we do is that we usually chain the function together with a dot sum, which sums up all the true and false. So true has a value of 1 and false have a value of 0. So by chaining isNull.sum, it returns the number of null values within each column because the .sum method sums up each individual column. So you can see that continent and location have 2 and 3 null values respectively. Total deaths, new deaths, and total deaths per million have 58, and total vaccinations have 514. That's quite a huge number. So next up is how do we handle these missing values? There are two main methods how we do it. The very first one is removing the rows that contains these missing values. So we can do this via the drop_NA method, specifying axis equal to 0. When you specify axis to be 0, it means we are removing the rows. If we change it to 1, it means that we're removing the column. So if I run this, what it does is that it actually removes every row that has a null value. So if you look at the index now, right, the date is no longer in proper order, like from 11 to 12 and John to 22, because the rows in between have been removed due to null values. But what this does is that it removes every single row with null values in the data frame. But what happens if we only want to remove rows containing null values of a specific column, for example, new deaths? Okay, so this is an exercise for us to do. I'll code along with you. So it's actually quite simple. What we do is instead of calling the drop any method directly from the data frame itself, we can first filter it based on the column we want to remove. So in this case, it's new devs. So first we filter the new devs column and we drop any of that column. So it returns that column with all the NA removed. So that's the difference. So it's quite a simple exercise. So the second method of handling null values would be filling in the missing values with your own values or an aggregated value. So let's try filling in the categorical columns. So the categorical columns we have is, in this case, will be continent and location. These two columns have missing values. Let's first fill with the continent one. So for this data set, since we filtered based on Singapore, the continent should all be the same. In this case, it's Asia. So what we can do is that we filter the continent column itself and we call the fill any method specifying the value we want to fill the null values with. In this case, it's Asia because we know for sure that Singapore is in Asia. So if you to run this, it will fill in all the values, all the missing values with Asia. So there's an in-place parameter where we can specify it to be true as well. So if you call the is now .sum, you can see that the continent has been removed. The continent missing values have been filled. Yeah. So another way we can do it is through a dictionary. So we can call the fill any method and then we include a dictionary with the key value mapping. The key would be the column you want to fill the missing values of, and the value would be the value itself you want to fill in. So in this case, we specify continent and the missing values you want to fill in with Asia. So since we already filled it beforehand, this will not really do anything right now because the missing values have already been filled. But for now, let's fill in the location as well. You can see that location have 3 missing values, and we want to fill with Singapore because this is a Singapore data set. So we can do the same by putting in a dictionary, key value mapping location and Singapore. So by running this and we check the null values now, you can see that now there's no null values in location because it's being filled. It has been filled already. So next up, let's fill in a numerical column just for example. So we can call the fill any method of the numerical column, and we can fill in the value of an aggregated value. So in this case, we want to fill in with the mean of the column itself. So we can get the mean of the column by calling this. We call the column itself and dot mean, which returns the average value throughout the whole column. And we put it as the value parameter in the fill NA. What this does is that it fills every single null value with the mean of the entire column. Okay. So if you were to run this, you can see that there's so many values with the same value itself now because it's most likely the mean. Okay, so we have come to the end of the very short data cleaning. So what's next is data visualization actually. So here we input a picture of the data science process. Right now, what we have did is a very small portion of data cleaning. So we are only here. So there's still further exploratory data analysis, which involves a lot of visualization, which will be taking place next week. Okay, so I included a small section at the back, which shows a proper way of cleaning numerical column in this case, because this data set is a COVID data set. So it's known as a time series data set. So the values itself are a function of time. So it's not really logical to fill the numerical columns with the average. So there are methods for forward filling and backward filling, which I leave it to you to explore on your own. I've included a code segment here, as well as further links for readings at the end. So this is a sneak peek on what you can do with data visualization. So this is known as a geographical plot. So you can visualize data using a lot of different visualization models. So do sign up for the visualization workshop that's happening next week to learn more about this. And here are the self-learning resources that we've added for you to read on your own. So do take some time to explore what Numpy and Pandas have to offer and more about how to do your own data science analysis. So So I'll pass the time back to Javier.
Okay, yes, hello again. Yeah, we are almost ending. So we've just, Python is very widely used for data science, right? And if you see here on the screen, there is so many different libraries that we can use. And we've only just covered Numpy and Pandas, which is the two most fundamental ones that we have to know before we can move on to other stuff. Okay, so next week, we'll be going through data visualization, which is using the Matplotlib, Seaborn libraries and other stuff. So yeah, please do sign up. You're gonna create like super nice looking plots. And then you see Python also has like sklearn, Keras, TensorFlow for like machine learning and deep learning, which we might have some workshops on. Okay, and yes, okay. So now we would love your feedback. So if you like the workshop, please tell us. But if you don't, then please also tell us. We would love to improve, and we will appreciate it if you could be specific, like which part of the workshop wasn't that good and which part could be improved on. Like, was it too slow, or was it too fast, or it's not comprehensive enough, or the explanations were not clear enough, and this kind of thing. Please do the form and tell us so we can improve for our further workshops. Okay, and yeah, do stay updated with us through our social media. NUS Statistics and Data Science, we have Telegram, Instagram, our website, and you can find all the links through our link tree. And NUS Hackers, they also have Telegram, Instagram, and website. So yeah, we're gonna host a lot more interesting workshops. So go and follow us. Okay, so now it's about lunchtime already, and we've come to the end of the Numpy and Pandas workshop. So enjoy your weekend and enjoy your lunch. Thank you for coming. Yeah, play some music while you guys leave. Oh yeah, if you have any questions, you can stay back. You can ask us here if you want. You can, if you don't mind, you can unmute and ask, or you can still ask on Slido. Yeah. Thanks for coming. Bye-bye. Bye-bye. Enjoy your lunch. Google Colab. You can also ask in the Zoom chat if you want, or if you're shy, you can PM either one of us from SDS.
Do you want to see the feedback?